Alright guys, today we're looking at section 2.3. So your learning goal today is that you want to be able to graph parabolas. And we've done that to some extent, but you also now need to be able to state the vertex. Done that, check. But we're going to be talking about this new point called the focus, this new line called the directrix, and another line called the axis of symmetry. We also want to be able to find the equation of the parabola if we're given any of these parts. So first of all, well, what is the focus? Well, if I have the axis here and I have some point right here, we're going to call this the focus. It is always going to be p units away from the vertex. So let's say that right here is my vertex. That distance right there is going to be p. The directrix is going to be a line perpendicular to the axis of symmetry. Here's what the axis of symmetry does. It comes right down there through the focus and the vertex. And this directrix is going to be p units from the vertex. So here's the vertex. I'm going to go out p units, and this directrix is never going to go inside the parabola. So here would be the directrix. I'm just showing you how it's all formed. There's the directrix. And so the parabola is going to be the set of all points that are equidistant from the focus and the directrix. This point right here, it's p units from the focus, it's p units from the directrix, so that's our vertex. Now, the next point I might want to create is another point that's going to be the same distance from this as it is to this. So I'm just going to kind of eyeball it. I'm going to say this point. So if I could measure this distance and that distance, they would be the same. Okay, and let's say that this parabola then goes out like this. So that means if I take another point, this distance should be the same as that distance. Okay, then I know that the parabola is symmetric, so it should look like this. So if I take this point, that distance should be the same as that distance. Now I have to have drawn that completely perfectly for that to make that the case, but that is how a true parabola is created, by having each of these points the same distance from the focus as it is to the directrix. Alright, so equations now. If we have this vertical axis of symmetry, that means that our parabola is either going to open up or down. If this p-value is greater than 0, it's going to open up. If it's less than 0, meaning it's negative, it's going to open down. Up to now, this value right here, we've always called it a. So we've looked at y equals ax squared. And we've just talked about this a value is going to be a vertical stretch or it's going to be a vertical shrink. Well, now we're going to be more specific about it. Instead of calling this a, we're going to call it 1 over 4p. Okay? So whatever's in this spot is now going to be 1 over 4p. This focus right here, whatever that p value is, that's going to be where the focus is. And the directrix is going to be in the opposite direction from the vertex, p units. Okay? Remember that focus is always inside that parabola. See how it's inside? That directrix is never going to touch that parabola. Okay? So it's always going to go in that opposite direction, never going to touch the parabola. Now, we can also have this horizontal axis of symmetry looking like this. Okay, so looking like this. When it looks like this on the axis of symmetry, this is going to be an x equals y squared equation. So now y is going to get squared, and that's going to look like this or this. When p is greater than 0, it's going to open to the right. When p is less than 0, it's going to open to the left. Okay? And here's some formulas for the focus and the directrix. I don't like to use the formulas. I like to just figure it out, and you'll see as we go what that means. All right. Write the equation of the parabola if the focus is 0, negative 4, and the directrix is y equals 4. So I'm going to draw a picture here. Focus is over 0, down 4. Here's my focus. Directrix is the equation y equals 4. That's a horizontal line. Right there's the directrix. Remember what we said. The parabola can never touch the directrix, and it wraps around the parabola. It wraps around the focus. The parabola wraps around the focus. in between that directrix and that focus, that's where that vertex must be. So right there's my vertex, right there at the origin. Because the parabola has to wrap around the focus, it's going to have to open down like that. This distance right here, that's going to be the p-value. So how far is that? From 0, 0 to 0, negative 4. That is going to be a distance of 4, so my p-value is going to be negative 4. So now to write my equation. Well, this is a parabola that opens down, so it's going to be y equals 1 over 4 times p is negative 4, and then it's going to go x squared. So the equation is y equals, and I just like to put the negative right there in front. That's going to be the equation of that parabola. So it's going to have this focus and this directrix. Okay? So if we had thought of this as being an a value, you can see that the negative would make it flip, and the 1 over 16 is going to be a vertical shrink. And that vertical shrink is actually going to cause it to be fairly wide. Okay? All right, let's look at the next one now. Look at the difference. This time y is getting squared. Here's what form we need it in. See, both of the forms are either going to be y equals or x equals. So I have to get the x by itself in this case to use my process that I've been using. So all I'm going to do is I'm just going to do the symmetric property. I'm just literally going to switch these around. I just wrote the same thing, but just, wrote them on opposite sides. To get x by itself, I'm going to divide both sides by negative 12. So now my equation becomes x equals negative 1/12 y squared. To use the formula, the numerator has to be positive 1. So that really means that this is going to be negative 12. Okay? So I would now know that 4p has to be negative 12, so p is going to have to be negative 3. Now, the vertex, I don't have any shifts left or right, so my vertex is just going to be right here at 0, 0. It doesn't ask me to find that, but I might as well. Now, I have to figure out which way this is going to open. If it's x equals, and y is getting squared, and that p-value is negative, it's going to open here to the left. So my parabola then is going to have to open here to the left. It's going to open that way. So I'm going to want to go, I'm going to have to go 3 units over here to the left, and that's going to be my focus. So the focus then is going to be negative 3, 0. Now the other thing I'd like for you to understand is that this number right here, this is also going to tell us the width of it. It's kind of a tricky thing, but it means that it's going to have a width of 6. I'm not going to check you on that, but that is the way it works. So through that, around that focus, it's going to go 6 units up and down. That's just something we'll get into more deeply later, but it has to be a total of 12 through the focus, and so I went up 6 and down 6, and that just shows us how wide that's going to be. All right, and then to find that other point that I'm looking for, which is going, not point, but line, that directrix, that's going to be p units, 1, 2, 3, outside. Okay, so it's going to be 3 units outside. It's not allowed to touch that parabola. So that directrix is going to be x equals 3. The last thing we have is that axis of symmetry. And that's going to go right here through these points. It's going to go right through the middle. Axis of symmetry means it's symmetric on both sides. And that's going to just be the line y equals 0. So these were the 4 pieces of information that we were asked to find. Okay? All right. Now we're going to change that vertex. Over on the other side, that vertex was at 0, 0. That makes things pretty easy. But now we're just going to have a new vertex. This vertex is still going to be HK, just like we talked about before. Again, we have these formulas for the focus and for the directrix. I personally don't like using these formulas. I just like to use understanding the whole process about the P units and everything. So that's the way I'm going to describe it. But you should know that if we have y equals x squared, that's going to be a parabola that opens either up or down still. If we have x equals y squared, then I'm going to have a parabola that opens either right or left. One thing to be careful about is whatever goes with the y inside of here, that's going to be the y value of the vertex. This number here is going to be the x value of the vertex. That vertex is very important to be able to find. Right there's the vertex, HK. All right, so now we're going to try to graph this and we're going to find all this information out. So the first thing I'm going to do is I'm going to find the vertex. They never ask us to do that, but you have to know that in order to find everything. So the vertex is going to be -1, we have a shift to the left 1, down 3. So there's going to be our vertex at -1, -3. The next thing I want to look at is which way it's going to open. If it's y equals x squared, it's going to open up or down. This is a positive, so I know it's going to open up. Now I'm going to find that p value. That's based off of this right here. 4p equals 4, p equals 1. So I know that focus is going to have to be up 1 because it's going to have to be inside that parabola. So that focus then, if I go up 1, this point is going to be -1, -2. All right? Now, while I'm graphing it, this number tells me how wide it is through the focus. So it's going to be a total of 4. So I'm going to go over here too, and over here too. Just helps me get a nice graph. I'm not going to ask you what those points are, but just understanding that it does give us a nicer looking graph. Okay, so now I'm going to go ahead and find that directrix. That directrix has to be outside of the parabola, and it can't touch it. P units. P was 1, so I have to go outside of it and create this line right here. That's my directrix. Because it's horizontal, it's going to be y equals, and what does y equal right there? Well, y is always going to equal -4. So that's our directrix. The axis of symmetry is going to be this line that comes down right like that, and that's going to be a vertical line, so it's x equals, and it's going to be x equals -1. Notice how that's what my x value is there, -1. Then I like to double check, did my focus go up 1? Did my directrix go down 1? Looks good. So this is all the important information for that parabola. All right, going in the other direction now, coming up with the equation. I like to graph as I go, and that's going to be helpful for a lot of you. Focus is -2, 0. Directrix is x equals 2. The vertex has to be in the middle of the focus and the directrix. So right here is going to be my vertex. So I'm going to go ahead and jot that down, 0, 0. That's always nice. The reason that's nice is because I don't have to worry about h and k. There's 0 and 0. Think about which way this parabola is going to open. Is it going to open up? No, it's not allowed to touch the directrix. Down? No. It's going to have to open to the left because it's got to wrap around that focus. It's got to look like that. That kind of a parabola is going to be an x equals. So it's x equals. Now I'm going to have to find that p value. P is going to be the distance from the vertex to the focus or vertex to directrix. That's 2 units. Because this focus and the parabola are off to the left, P is actually a -2. So, using my formula, the formula is going to be x equals 1 over 4p y squared. That's our formula. So, plugging in -2 for p, x equals -1/8 y squared. And that's going to be the equation of the parabola. Look at the next one. This time we have a vertex of 0, 0. Our focus is at 0/4. Fraction, it's all right. Don't have to be exact, just getting an idea. I knew it had to open up because the focus has to be inside that parabola. When it opens up, it's y equals 1 over 4p x squared. That's the formula we use. So this is going to be y equals 1 over 4 times that p value. That distance right there is going to be 4/5. So down here I'm going to have to do 4 times 4/5. Well, 4 times 4/5 is going to give me 1 over 16/5. Now, here's the problem though. I should really never leave this as a complex fraction, as a fraction within a fraction. You really shouldn't have fractions within fractions or decimals within fractions. I will tell you that when you do your homework, they do leave a decimal within the fraction. So keep that in mind when you're doing big ideas. But for us, we're going to be correct in our notation. So what I'm going to do then is, I want to change this. So what is 1 divided by 16/5? Well, that's 1 times 5 over 16. Well, that's just 5 over 16. So another name for this would just be 5 over 16 x squared. And that's better than that because I don't have a fraction within a fraction. Now, if I had to go back and get it into this form again, because I needed to find p, I'd have to divide the top by 5 and the bottom by 5 and see how that would get me back where I started. A couple more here. Identify the focus, directrix, axis of symmetry, and graph. All right, we check it out. So right here, this is a negative, so I'm going to go ahead and put that in the denominator because that's going to have a 1 on top. So I'm going to do 4p is -12, p then is -3. I'm going to find my vertex, even though they don't ask for it, we need to know it, 2, 1, hk. So I'm going to put that 2, 1. Okay, and so I have to figure out, does this open up, down, left, or right? It's y equals x squared. It has to open up or down. P is negative, so it's down. Find the focus by moving down 1, 2, 3 units. Right there is going to be our focus. So that's going to be the point. 2 and then -2 is our focus. Our directrix, we have to go 3 in the opposite direction. Vertex, focus, directrix, go 1, 2, 3 up, and this is going to be a line like that. That directrix is always a line. So that line is going to be y equals 4. You can see that that's what y is always equal to. So that's my directrix, and then the axis of symmetry finally, that's going to have to go through that vertex and focus. I'm going to graph though. It's going to be 12 units total through the focus. Just kind of estimate that. You don't have to be real super exact, but if I go left and right 6, that's going to give me a pretty nice graph. So that axis of symmetry then is going to be this right here. So it's going to be x equals 2. And that's going to be our graph, our information and our graph. Look at the next one. This is one where they didn't put it in the right form. We need to have y by itself or x by itself. So I'm going to just flip this around and make it this. -2y equals x squared. I now would divide by -2. So I have y equals I'll just make it 1 over -2 x squared. See, this is a negative, and it's really down here in the denominator because that's where I need it to be. So that means then that we're going to have 4p is going to have to equal -2. Well, P then is going to have to be -1/2. Okay, so let's find our vertex. Our vertex is at 0, 0. I have to figure out, is it opening up, down, left, or right? Well, if x is getting squared, it's going to open down again. And so I'm going to have to go down 1/2 unit for the focus. So that focus then is going to have to be at 0, -1/2. And that directrix is going to have to be up 1/2 unit. So that directrix is going to be y equals +1/2, and that axis of symmetry is just going to go straight down through like that, and so that axis of symmetry then is going to be x equals 0. And then just a real quick sketch, it's going to be out 1 unit in each direction from the focus. It's going to be very narrow like that. Okay. So there we go. That's our important information. All right, so now we're supposed to write an equation for these. They give us a picture. We'll figure this out. Here's our vertex. That vertex appears to be at 0, 0. And this time we've got a p-value. That's going to be how far apart are those, and it's -7/12. It appears as the distance. So that's going to be my p-value. Because this opens to the right, it's going to have to be an x equals y squared, 1/4p. By the way, this p is actually positive, not negative, and that's because it opens to the right. P must be positive when it opens to the right. So we've got this, and so we're going to now simplify this. So we're going to have x equals 1/4 times 7/12 on the bottom, y squared. So that's going to be 1 divided by 28/12, which is 1 times 12/28. I got to get rid of that complex fraction there. See right here, this is going to be 28/12. So I had to do 1 divided by 28/12. So it's 1 times 12/28. Divide this by 4, divide this by 4. So x equals 3/7 y squared. That's going to be the parabola that looks like that. All right, so you could stop the video there if you want to do this one. I'm going to do it very quickly. You can try it too on your own if you'd like. Just pause the video if you want to. So hopefully now you can find that focus, that directrix on your own, as well as graph based on the information and find equations.